One of the most fascinating properties of waves is how they interfere with one another. So when waves meet, they can add up or subtract from one another. They combine. And when they do so, they pass through one another without affecting or destroying themselves. So this is described by what's known as the superposition principle. When two or more waves encounter each other, the resultant wave is found by adding together each wave's displacement point by point. Superposition principle is really, really powerful in general, and in fact, it forms the basis for all sorts of seemingly unrelated fields, such as acoustics, quantum mechanics, and then just descriptions of kind of everyday waves in nature, like water waves or seismic waves or waves on a string. Now, the superposition principle is only approximately true when you're talking about waves in a physical medium. Because, for instance, if you have waves on a string and they're combining or adding together, they can't just keep adding to bigger and bigger displacements. Like, I can't just keep stretching the string on the guitar farther and farther. At some point, it would break. So there's kind of limits to the superposition principle in a physical medium, but mathematically, there's no limits to the superposition principle. And if you're talking about adding electromagnetic waves together, or you're looking at quantum mechanical wave functions, there's not really any limit to the superposition principle. So let me show you an illustration of what two types of interference look like. These are called constructive and destructive interference. So constructive interference is when you add waves that are in phase. So they have the same wavelength and the same phase as one another. Let's see if this pen works. Not so much. Okay, that's all right. So let's say I have one wave that looks like this. And in the same medium, I now send a second wave in that looks like this. The superposition principle says that these two waves are going to add together, point by point. So at each point, like this point, for instance, we'll take the amplitude of the first wave, the dotted one, and add it to the amplitude of the second wave, which would give you a point up here. And if you do that at every point, for instance, this one, you take this amplitude and add that amplitude and you get a point here. You get a combination. I'll try to draw this so it looks a little different. Draw a thicker line. can tell the difference between those, but the point is that these two original waves added together to give you a resultant wave that's the sum of them. So it has a bigger amplitude. Now there's destructive interference. This happens when waves are out of phase with one another. So let's start with our same original dotted wave. And let's add the second wave, except put it 180 degrees out of phase. So let's do this. Now watch what happens when you add these. This wave is negative. This wave is positive here. I'm looking at this point. So when you add them together, you get a value, it's about here. Now let's look at this point. This one's positive, this one's negative. So when you add them together, you get a point that's about there. So now our combination looks like this. This dotted wave has somewhat destroyed the other wave because they're out of phase. That's destructive interference. Now what's really cool about destructive interference is if you do it with two waves that have the same amplitude and are 180 degrees out of phase. So let's try that. So what if we have this Well, take a look at this point. If you add this guy, negative, plus this one, positive, they're the same amplitude, opposite signs, it gives you 0. And that's the same is true everywhere. So these two waves just cancel each other out completely. You get 0 everywhere. So this is completely destructive interference. And if you've ever used noise canceling headphones, this is how that works. Noise canceling headphones have a microphone on them. That microphone listens to the sound that's around you from the environment, like the air conditioner in my house right now. It listens to that sound or conversations of people around you. And it plays that sound back, but it flips all the waves in that sound by 180 degrees. So this dotted line would represent the actual sound coming from the environment. The solid line would represent the flipped sound that was heard by the microphone that's now getting played in the headphones. And those two sounds, the environment and the playback, completely cancel one another through destructive interference.